Alrighty, we are continuing our study of exponential functions. Instead of doing exponential growth like we did in 5.3, we are moving on to exponential decay. So the start thinking part here says that if you had an item that cost $30 and it was discounted by 35%, what is the single number that you could go over and multiply by to take care of the fact that you are decreasing by 35%? Now, exponential growth it's a little bit more intuitive, meaning 20% growth, it makes sense that it would be 1.2 because you have your 100% and then an extra 20. But this gets really confusing because a lot of students think, oh, 35%, that's 0.35 multiplied by 0.35. But that just doesn't make sense because if you take 30 and you multiply by 0.35, it makes it so that you have barely anything left. And we know 35% decrease means that you still have more than 50%. So it just doesn't make sense to be multiplying by 0.35. So in this case, you would actually be multiplying by 0.65. And the reason why is you are thinking of what is the number I can multiply by that represents how much I have left. So if you have 35% going away, then you have 65% left. And that's why you multiply by 0.65. I still have 65% left. 100% that I normally have, which is my own money. When I take away 35%, that's 65%. Now, the first situation here, it says the number of fish decreases exponentially after a stocking. The original was 2,000 fish that are stocked, and it's going to be decreasing by 10% per month. The idea here is you dump a bunch of fish that aren't actually wild, and they get picked off by being caught by people and by being caught by birds. They're not used to being in the wild. So it drops by 10%, and then the new one drops by 10%, and so on. So it says write the expanded expression to represent the number of fish after 4 months. So since it is 10% going away, you still have 90%. And that's why you multiply by 0.9 4 different times for 4 months. The next one says write that using a exponent, and that is 2,000 times 0.9 to the 4th. And then lastly, it says how many fish are there going to be after X months. So all you have to do is change out the 4, which is the number of months for X. And this would be just a generic equation that you could use in general to find out how many fish there are going to be. If there was a 20% decay, you can see the work I have there. You're just multiplying by 0.8 instead of 0.9, and you can see how that works. The students were supposed to look at this and figure out what is the general format that you would have for the formula for exponential decay. We know exponential growth is y equals a times 1 plus r to the x, and it seems like all you did was take 1 and subtract the rate for decay, and that is exactly what we do. You just have y equals a times 1 minus r to the x. So let's go ahead and look at some possible applications to this. So one of the things is if you have a warm water bottle or something like that, it will cool down exponentially. At first, it cools down by several degrees, then a little less degrees over the next hour and a little less the next, and it's actually modeled by exponential decay. So this says Marlowe is going outside to shovel snow and decides to bring a cup of hot chocolate. The cup cools exponentially at a rate of 45% per hour. The liquid is 50 degrees. Originally, and how much is it going to be after 3 hours? So you have your original of 50, that's where the 50 came from. The reason why it's 0.55 is because if you had 100% and it goes down by 45%, then it is going to be 55% left. And that is why it's times 0.55, and that happens 3 times. So that's to the 3rd. You might ask me, why did I even mention the fact that it was 0 degrees Celsius outside? And the reason why is these exponential decay functions, if you go bigger and bigger and bigger numbers, it is going to be approaching 0. So let's say it was 70 degrees out. We all know that if you bring a hot cup of coffee and let's say you're in a classroom that's 70 degrees, the most it's going to cool down is to the temperature, the ambient temperature, which is 70. So this wouldn't have made sense for it to keep going down unless the temperature outside was 0 degrees. So it can go all the way down and get infinitely close to 0 degrees. The next one is the half-life, the amount of time it takes for half of the medicine to be metabolized by your body. For aspirin is going to be 2 hours. That means if you take the pill, 2 hours later, half of it is gone. And then 2 hours later, half of what is there now is gone. And it just keeps happening until it decreases, until it's pretty much gone from your body. So we're supposed to be writing the exponential decay function for this. So you have your original, which is 200. You do 1 minus, and half is 50%, so minus 0.5, and that's all to the x. That x represents the number of 2-hour periods. So a lot of kids were used to saying, oh, 6 hours, let's just substitute in 6. But the number of times it's halved. If it's every 2 hours for 6 hours, is only 3 times. So it's going to be raised to the third power. When you put this to your calculator and crank through it, you find out that there'll be 25 milligrams left. The only other way we could work with this so that you didn't have to think of how many times does it happen is you can see I put x over 2. That way when you do your 6 divided by 2, that will give you your 3. So x then becomes the number of hours, not the number of times it happens. So this next application here brings up some of the common misconceptions. So Kira is told that the value of her car will depreciate exponentially by 20% per year. The car was originally $18,000. Now, depreciation just means that right after you buy a car, it drops by a certain amount, and then it drops by a certain amount every year as it moves on, and that's usually exponential. Okay, it's not linear, it's exponential. So on here, it says that she's worried that her car is going to be worth nothing in 5 years because 20% for 5 years is 100%. All the value would be gone. So is this correct? And the answer is no, because you're always taking 20% of a new number. First, you take 20% of 18,000, then you have a new number, which is 14,400. Then you take 20% of that. So you keep taking less and less amount of dollars away. The other way you can think of this is if you're taking away 20%, you are left with 80%. So how could you ever end up with nothing if you're always taking something away, but you're leaving something? It's impossible for it to become 0. So then you get your equation, which is y equals 18,000 times 1 minus 0.2 to the x, which is 0.8 to the x. And the students then just substituted in 0, 1, 2, 3, 4, 5, and 6 to find out what the values were. And after you had that, you can see your exponential decay. You can see how that is like a curve that is curving down. And we had talked about something called an asymptote before. This one is going to have that asymptote at 0 because the concept is it will never reach it'll never reach 0 because every time you take 20% away, there'll always be 80% of the remaining left. Now, the next question was, when does most of the change happen with exponential decay? In this case, when does it lose the most dollars? I know it loses 20% every single year, so the percent will always be consistent. But when is it going to lose the most dollars? Now, there's 2 different ways to think of this. You can just look and do your calculations and find out that it's between 0 and 1, or you can just use logic. When you find 20% of a bigger number is bigger than 20% of a smaller number. And the biggest that the number is ever going to be in this case is 18,000. So when you take away 20%, that is going to be the largest decrease. And then after that, the number just keeps going down and keep taking 20% away from a smaller number. The next one says, a different vehicle depreciates at a different rate. The equation that represents the situation is as follows. Explain what all this means. You know the number 30,000 is the original. So that is the original cost of the vehicle. And then you got to be careful because 3/4 is 0.75. And it's very easy to think that that means that it depreciates by 75% each year. But that's saying you have 75% left. So if it goes down by 75%, or sorry, if you still have 75% left, then it must have gone down by 25%. So it's 25% depreciation each year. Now let's take a look at your homework. So this first one is talking about the number of termites. You start with 28,000. It decreases exponentially. First you kill off a bunch of them, and then it kind of slows down, and it takes a while to get rid of all of them. Decreases by 22% each year. So in this case, you're going to do 28,000 times 1 minus 0.22 to the x, which is the same thing as 28,000. 28,000 times 0.78 to the 7th because it's 7 weeks. And you find that after 7 weeks, there's still going to be 4,918 left, as long as I did that math correctly. And then it would just keep going on and on until the population got so low that it could not maintain itself, and then it would be done. The next one says a bicycle sells for $300. It's a fourth off the regular price. Select all that makes sense. A does not make sense to talk about the sale price because it's not a fourth of the cost. It's not like 3/4 went away. B does make sense because that's just saying that a fourth went away and you're left with 3/4. The next one is correct because that's the same thing as saying multiply by 0.75. 3/4 is still there. D doesn't make sense because that's just saying subtract the number, which is 1/4. The cost is not going to just be take away a fourth, it's a fourth of the cost. And then the last one does make sense because it is the cost minus a fourth of the cost. Now on the next one, it is talking about folding a piece of paper. This is going to be exponential decay as well. The situation is 90 times 1/3 to the n, and this is asking what is actually happening. It's saying folding a piece of paper into thirds. So what is the a when n equals 0? Well, we already know anything to the 0 power is 1, and 1 times 90 is 90. So that means you have 90 at 0, and that means the original area was 90. The next one says how many folds are needed before you have less than 1 square inch. I just went over and started testing numbers, and I found that 4 was too high. It would still be over 1 square inch. And then 5, put it under 1 square inch. So the answer was 5 folds. The next one says we have a different piece of paper. Here is the equation that models this. What does the different parts mean? And this is saying that the original was 100 and that it's half the size every single time. So you're folding it in half each time. Now the next one is talking about two different situations. One is where the rate is increasing at 40% per year for 5 years, and the other one is decreasing at the rate of 40% per year for 5 years, and that's per year. And it's saying for the exponential growth, when is the biggest change going to happen? Is it between 0, 1, 1 and 2, 2 and 3, 3 and 4, and 4 and 5? And we know exponential growth, while the percent is always the same, the overall change usually is later on down. And if we're just going from 0 to 5, it's going to be between those last 2 hours. When you're talking about decrease, we know, we just talked about this in the lesson, most of the change, the percent change is always constant, but the overall change would be happening most at the beginning. So from 0 to 1. Next problem here is talking about an iPhone. Starts at $1,200, drops by 32% per year. What's that equation look like? You can see that it's y equals 1,200 times 1 minus 0.32 to the x, which is 0.68 to the x. Then you can substitute in your values to figure out what the value, or in the number of years to find out the values. And then we graphed it, and you can see that nice curve, which looks like exponential decay. And you can see here that the biggest dollar change is going to be the first year, and then kind of slows down. 2 more. Circle all equations that are modeling exponential growth. A is not it because that's linear growth. B, even though that first number is less than 1, which seems like it would be decay, the number that actually matters is the factor, and the factor is greater than 1. And whenever you multiply by a number greater than 1, it gets bigger, so that's growth. The next one is multiplying by a number smaller than 1, so it's decay. The next one is multiplying by the number 1. That just doesn't go anywhere. It doesn't go up, doesn't go down. The next one, 8/3 is bigger than 1, so that's going to be going up. And the last one, while this looks like it has no original, by default you have a 1 in front of there. So it's an original of 1 and a growth factor of 1.76, which means it is getting bigger. And the last one says, what is the percent decay represented by the following situation? So this is saying that you have 73% left, which means it must have gone down by 27%. So that's a 27% decay. Be very careful. I know that is going to be super tempting to say that means 73% decay. And one other thing that I wanted to note that I forgot to note in the previous lesson, take a look at this one right here. We know that it is 1 minus the rate, and yesterday it was 1 plus the rate. The biggest issue that I see people make is when they put the rate in, they put it in correctly. If it says 6%, they put the number 6 in, or they put the number 0.6 when it's supposed to be 0.06. So be very careful when you're putting that rate in as a decimal. Thanks for watching.